right, well, we made it. Today is the last day of September. Congratulations. We are almost to October. And believe it or not, this is about the third of the way mark of the class. We haven't even gotten out of September, and we're a third of the way done. Right, 1, 2, 3, 4. This is the 5th week. So, right, content-wise, there's actually not 15 weeks of content, right? Because we've got a week for midterm where there's no new content, and then there's final project work time, there's no new content. Right, so like in terms of content, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 weeks of content, and we're in 5. We're almost halfway, actually, content-wise, which is cool. So it's a lot, right? We're getting into it. It's all new stuff. It's good. Python's a lot of fun. Are you keeping up with iBooks? I was about to look here. I wanted to see. Does not look like we're keeping up with iBooks very much. You're not going to lose points, but like this is another one of your practices, right? I'm going to show you one way, the book is going to show you another way, you're going to practice in the book, you're going to practice in the lab, and then you're going to do the project. So that's like 5 times you're getting this to hopefully get it stuck in your head here. And if you know anything about how human memory works, if you do all 5 of those on the exact same day, you're not going to remember it very long. Right? The idea is that you want to repeat these things over and over and over so you can keep it in your head a little bit longer. Not that you have to memorize stuff, but you want to recall some of the information here or know where to go find it here. So that's why we have a lot of practice. That's the goal. The only way to get good at something is by actually doing it, right? I don't know how many of you folks are fans of basketball, but I can watch basketball all day long. I'm 6'2". I'm not good at basketball unless I actually play basketball, right? And I don't play very often because I'm terrible at it. It's like self-fulfilling prophecy, I guess. But that's sort of the idea here. Why did it go there? No. What is it doing here? I don't want. Okay. What did I click on? I don't know what I clicked on. So yeah, we're cruising right along. Remember, the projects are worth 30% of your overall score of the projects category, right? So we're going to have the projects. I fixed the dates here. So we've got our 4 projects. Of course, we start counting at 0 because that's how all people count, right? Normal people count starting at 0. Or at least us programmers do. We're going to talk about project 1. I just posted it today. We'll talk about that one and loops, and then we'll go practice loops in lab. It's a lot of L's there, but that's okay. And we'll keep on going, right? So if you didn't get project 0 in, it's not the end of the world. I think someone said it was actually easier than the labs. That's fine, great. This was a pretty quick one. Project 1's a little bit trickier. Project 2 will get a little bit more interesting, and then Project 3 should be a lot of fun. And then we'll have the final project, right? Which will be the most fun of all. And yeah, we're cruising right along. So let me fire up PyCharm here, and we'll take a look at the project. Come on, computer. PyCharm. Maybe. There it goes. I don't know what my computer's unhappy with today. And we'll go look at the assignment here. Project 0. So I'm not going to do this repository, right, because this would make me the private one. You all went through this one. I'm going to put it in the class one here. And we're going to plan our little party here. So let me fire up a new project. Call this one Project 0. Right, it's in my Git repository folder. That's where I want it to be. You'll pick your Git repository folders later. And you don't want to check this create Git repository box. That's the bad one. You have to go delete that hidden.git folder. It works out okay, but it's just more work for you. And then creating a welcome script is fantastic. We like that. Sorry, my phone should probably be on silent here. There we go. Found the right button. All right, so we need their name, and then we're going to use their name in all the prompts. So that's the very first bit here. We have to ask, hey, welcome to our party planning program. What's your name? Right? We can pretend like our computer cares about us, right? Sure. We can go ask for their name. So name, that is an input of welcome to the party planning program. What's your name, friend? Whatever you want here, right? I don't really care what your prompts say. This part's the fun part for you. You want to be silly, be silly. If you just wanted to say, enter your name, that's fine too. It's okay. And then now we need to have the number of people, right? Number of guests is going to be an int of an input, because you're probably not telling me there's 12 and a half guests at your party. Probably not. maybe, but int is probably a safe bet here. And then if we want to include their name, probably easiest to be a formatted string, right? Because then I can drop name in here. How many guests are you expecting? Right, and then we'll get that value. Right, so we've got name, we're using all the prompts, we have how many guests. And then we get, what are we serving? Pizza, drinks, or ice cream? Right? Okay, sure. So then the, I don't know, serving is an input. Again, a formatted string here. Let's copy that or something. It's not, that's too many quotes now. What are you serving? Pizza, ice cream, was it pizza, drinks, or ice cream? Drinks or ice cream. Sure. Now, if we're going to be comparing this string to see did they enter pizza or did they enter drinks or did they enter ice cream, we could just lowercase it now, right? So I could just say dot lower now, or I could do that in each of my checks. Either way is perfectly fine. I prefer to do it once rather than 3 times. So I'm just going to lowercase it as soon as I get the input right away, rather than saying, okay, if they entered this dot lower equals, right? We can say if serving dot lower is equal to pizza. You could do that in each of your ifs. Again, I don't want to have to type it 3 times, so I'm just going to drop it here once. So if we're serving pizza then, right? Now I have to do this thing. If we're serving drinks, we're doing this thing. If we're doing ice cream, we're doing this thing, right? So sure, so if it's pizza, something here, elif. If our serving is drinks, elif. We're serving ice cream. I can't find my quotes. Ice cream. Else. Print. I can't help you. Please try again. I don't know, something, right? I didn't know what it was here. Was no good, so sure. If you didn't even have that all, it's probably okay, right? I don't think it's specified here that you had to tell them, but it's just probably a nice thing to have in here, in your program, that else case. Doesn't have to be here, but again, it probably makes sense for it to be here. And then if you want these to be ifs, you could. It's just slightly less efficient because then it's going to check every single one of them, versus if it's if, else if, else if, else if, one and only one of them will run. It makes them mutually exclusive, and then my last else actually works here. So if I want to have this last else, I need all these to be chained together rather than if, just standalones. Probably just a style preference, but all right. So if we're serving pizza, right? How many slices will the average guest eat? Okay, so this is slices per guest then. Is going to be probably an integer, right? Maybe a float, but most people don't eat half a slice of pizza. That's kind of rude. I mean, maybe they only leave it on their plate, but they don't like take half a slice of pizza off of the pizza container. So, how many slices will the average guest eat? Okay. Now, number of guests is like if you invite 10 people to a party, there's actually 11 people at your party because hopefully you showed up too. So we could just add 1 here. Number of guests is a little bit misleading then, so maybe we call this number of people at party, or maybe just number of people. That's probably fine here. And then we'll just add 1, right, to account for ourselves. Otherwise, I'm going to have to add 1 later on, right, because you want to eat your pizza. Right? Don't forget to order pizza for yourself. Right? All right. So how many slices will the average guest eat? Great. So then I need to have total slices. Slices needed then is going to be my slices per guest times my number of people. Right, that's some quick arithmetic, nothing hard here. And then we're going to ask how many slices come on a pizza. I guess we could have done the arithmetic before or after, that's fine. So we'll have slices per pizza is an int of an input. How many slices per pizza? I don't know, or something like that. I don't know if the question makes a lot of sense there. That's probably okay, right? And then we're going to calculate how many whole pizzas we need to order. Remember, math.ceil will round things up to the ceiling here. And then we have to ask for the cost of the pizza, display total number of pizzas, and the cost, okay? So then we need how many total pizzas then? Total pizzas, or pizzas needed. Pizzas needed is going to be my total slices needed divided by the slices per pizza, and all of that wrapped up with math.ceil. And now it says, oh, I don't know what math is. We can either go type import math at the top here, or the little light bulb here sometimes gives you good options. Just clicking this every single time if you don't know what it's doing is probably a bad idea. right? Because it will do things that are not helpful sometimes, right? So if you know what it's doing, yes, go click it, please. But don't just click the button and hope red lines go away if you don't know what it's doing for you. That's probably just a bad idea. Okay, so pizzas needed, we round up the total slices needed divided by slices per pizza. I think that math checks out, right? Okay, then we need cost. Cost per pizza. Cost per pizza is, maybe this one's a float now, because maybe it's, $5.99 per pizza or whatever, right? Because for some reason when we see $5.99, we don't think $6. And my daughter, who's extremely literal here, every time I tell her how much something costs, I add the penny. She's like, no, it's not, Dad. It doesn't cost that much. It drives me crazy. But she's extremely literal. She's like, no, $5.99 is not $6, Dad. Sure. Okay, so why not? How much does each pizza cost? And then we'll print out, you need to buy this many pizzas, and here's your total cost, right? So when we're done, print a formatted string here. You need to buy my pizzas needed. Pizzas. It will cost $, and our cost. Now we could do the cost per pizza times pizzas needed right in here. Right? You can do arithmetic right in these expressions if you want here, or you could make another variable for it. Doesn't really matter for our purposes. Either way. So you'll see me do either one. Yeah.
Is it okay if we put round instead of math.cell?
So round is not going to work, because if you're at 3.4 and you only buy 3 pizzas, people aren't getting their slices, and they're going to be sad at your party. You're going to have a sad party. Well, you'll be really embarrassed when you run out of food. It's terrible. You can't do that in the Midwest. It's not allowed. In fact, you're supposed to have extras and send leftovers home, right? That's how we have parties here, right? I don't know. That's what we do. My wife loves to feed people. All right. So that's sort of the idea. If you rounded, that's okay. It's like, I'll take like half a point off or something. It won't be a whole lot. All right. For drinks, we do the same thing, but now we have to talk about from ounces to gallons. So there's a little bit of extra arithmetic. Sure. So how much is your average guest going to drink? So this is ounces per guest, then, is an int of an input. How many ounces will the average guest drink? And this gets a little silly. Like, it's basically the same thing with different prompts, but that's okay. So now I have to convert that to gallons needed. Gallons needed, then will be my ounces per guest. Ounces per guest. I should have done milliliters, because ounces is a terrible measuring system. I forgot. Apologies. Ounces per guest times the number of people divided by, and then there are, was it 128 ounces in a gallon? Now, I feel a little bad having this here. So we could make a variable for that. So this is ounces per gallon, 128. Again, the convention is if we make it all uppercase here, we're saying, please don't ever change this. This is a value. You're not making it a static value, but that's what we would do in other languages. That's the convention here. If you see a name in all uppercase, don't change it here. So cool. And the order of operations doesn't actually matter here, right? The right thing will happen either way. I don't think we need any parentheses, thanks to math. Okay, cool. So we have gallons needed, and then we'll ask the cost of each gallon. So that says cost of gallon is probably a float of an input. How much does a gallon of drink cost? Again, I'm just calling it drink because it amuses me. I don't know we could ask them what drink they wanted to serve, but it doesn't really matter here, right? Oh, we forgot name. Uh-oh. I'm supposed to be using name everywhere. Shoot. So let's throw in the name here. Throw in the name. Our program's not friendly unless we're asking for their name. Name. Okay, we're getting there. Why do they do a single quote instead of a double quote? All right. And then we'll print. So you need to buy the gallons needed. Oops, a float formatted string of drink. It will cost, and that's my cost of gallon times the gallons needed. Now, we need whole gallons, so I should round that up as well then, right? So want to take all of this then and round up. Again, math.ceil to round up. Because of course, whatever we're serving, we're buying by the gallon here, because that makes sense. You probably serve milk at your party, right? Is there anything else you buy by the gallon? I feel like everything else is done in liters. You must have an amazing party with milk. I don't know. Sure. We drink a lot of milk at my house, so we go through gallons of it a week. Maybe that's what I'm thinking of. You probably have more interesting parties, but that's okay. And ice cream, the best here. So how many scoops will each guest eat? How many scoops come in a container? How many whole containers we need to buy? Again, we're rounding the cost of each container, so same idea here. So we have then scoops per guest is an int of an input of a formatted string. Like we're just chaining all these things together here. They get a little bit long here. And you all look bored already, I'm sorry. Name. Oh, I forgot name again here. Name. Look at that. We have to be polite. How many scoops will each guest eat? And then we'll have scoops needed is going to be my scoops per guest times the number of people attending. And then I need to know how many scoops come in a container. So scoops per container is an int of an input of a formatted string, name, how many scoops come in a container. And then we'll have containers needed then. Containers needed is going to be my math.ceil, right? We're going to round up of the scoops needed divided by the scoops per container. Cool. And then we have a cost per container. Here's a float of an input of a formatted string for name. Name, how much does a container cost? And then we can print out. You need name, right? Formatted string, name. You need to buy the containers needed. Containers. It will cost, here's my cost per container times the containers needed. All right, I think that's it. Now we need to try it, right? And for us to make sure that our program does what it's supposed to do, we need to know what numbers should come back out, right? Because we should need to understand the problem well enough to make sure that it's doing what it's supposed to do. Because if we got one of our multiplications or divisions wrong here, or we forgot to do something here, it's going to be wrong. So we can't just say, "Oh, I wrote the code; it's got to be right." Right? And really, at this point, like you probably can't even take this and hand it to ChatGPT and say, "Is this right?" Like, it might work. I've seen it have a little bit of luck if you use good variable names, but most of the time it's like, sure. Like it doesn't know what we are supposed to do. Like, so again, trying to use it as a tool to help you rather than do all of your work for you can't really do that. Now maybe you ask it the story problem and say, hey, come up with some numbers to test. It's usually pretty bad at math. I don't know how well I would trust it. Probably for this math, it's simple enough. It'd probably be okay. But anything too complex, and I start to lose faith in the machines. But let's give it a try. All right. So what's your name, friend? Eric. How many guests are we expecting? We're going to have, let's do 9 guests, so it'll be 10 total people. We'll make the math easy for us here, right? And what do we want to serve at our party?
Ice cream.
Ice cream. All right. Ice cream. How many scoops will each guest eat?
2.
3? Yeah, definitely 3 or more, right? That's good. So we should need 30 scoops then. And how many scoops can I contain? Let's do something that gets rounded up. 18? So 18 scoops per container. If we need 30, we're going to need 2 containers, right? And how much does each container cost? Let's just do something easy like $2.50. We need 2 containers. It'll cost $5. Awesome. Oh, I forgot my dollar sign. Doesn't actually matter, but nice to look pretty. All right, so ice cream seemed to check out okay. Let's try it again with a different one here. Eric, 9 guests here again. How about pizza? Oh, I missed a comma here. How many slices? How many? You can't run those things together here. Goodness, I did a bad copy paste here. It's embarrassing. Okay. How many slices will the average guest eat?
3.
3 slices, okay. So we're gonna need 30 slices. So how many slices come on a pizza? 10 slices per pizza. So that should be 3 exactly then, right? This is a good check, right? We don't want to always be increasing the value, right? So how much do these pizzas cost? What is it, $5.99 or something for the hot and readies? or they're more than that now, right? So 3 pizzas, $17.97. That's probably correct here. Like $6, yeah, minus 3 cents. Cool. So pizza's checked out. And then one last time, let's try drinks. 9 guests. We want to serve drinks. How many ounces will the average guest drink? 8 ounces? It's a very exciting party. Everybody gets 1 cup, exactly 1 cup. Sure, so we need 80 ounces. That should be less than a gallon, so we'll need 1 total gallon, right? 80 is less than 128. So how much does a gallon of drink cost? Milk is like, what, $2.59 a gallon at Meijer, I think? We need 1 of drink. Okay, it will cost $2.59. Checks out, right? So we've tested all of our things. We think it probably does what it's supposed to do. And then one last check here. Eric, 10 guests and serving garbage. I can't help you, please try again. Gibberish, this is what we'd expect. Like, I wrote the code. I want to make sure it does what I expect it to do. Because the general rule of thumb here when it comes to software is any software that's worth writing is worth testing. Does that seem to make sense? Right? If it's worth writing, it's worth making sure you did it right. If it's not worth making sure you did it right, why'd you write it in the first place? Right? You could just write garbage and no one cares if it doesn't do what it's supposed to do. Right? So anything that's worth doing, you want to make sure you did right here. So that's our testing. So we'll get to eventually making the computer test itself, which is really cool. And there's ways to do that, and it's a whole fun system. It's a whole process in software engineering that I'm quite fond of. But for now, all the testing we do is us. Come up with, okay, I put this in, this comes out. I put this in, this comes out. I put this in, this comes out. Because we have to understand the process well enough. And that works for anything, right? We always need to know what the problem is to make sure that we can write the software to make the computer do it for us. So if we understand what it is, we can also test it, right? And that's where a lot of people get into trouble sometimes. If you don't actually understand the problem that you're trying to solve, or you just like jump right in and you don't actually understand what's happening, it won't go well. So that's why this is a creative process, right? We're taking a big problem, breaking it down into smaller and smaller and smaller steps to figure out, how do I make a stupid computer solve it for me? And that's the goal here, right? And that's what's fun. I find fun. Like, it's like solving puzzles, essentially. How do I take something complex and difficult and break it down into small steps here? All right, we okay with the project? Let me commit that to GitHub. So again, that didn't take super long, right? Hopefully it didn't take you more than a couple hours. I know if you're getting into it, you're going to have a lot of red lines everywhere. Things are going to be having issues, and that's okay. That's part of the process, right? The more you practice it, the better you'll get at it here. So here's project 0. All right, commit and push. We can move on to loops. Go back to regular chapters here. Not reporting. Yeah, here we go. So loops now finally give us a chance to do something over and over and over again without having to copy paste. Because copy pasting is pretty sad here, right? So let me start a new project. This is chapter 5, loops. All right. So I think we looked at like the number guessing game before with our quick little example with the if-else, right? Hey, I'll generate a random number. We'll see if I guess the random number. Do we do that?
Yeah.
Okay, cool. I think we probably did. So, but it's kind of boring to like have one guess. And if I want to have more than one guess, I'd have to copy paste, copy paste, copy paste, copy paste. That feels really bad here, right? So it'd be nice if I could just make the code keep on running over and over and over again. So that's what we get to do with a loop. The idea with a loop is that your code will run over and over and over again until something makes it stop. So there's 2 different kinds of loops. There's while loops and there's for loops. So we're going to look at while loops first. So the while loop says, as long as something is true, keep on running. Right? So I can say, here's my number is 10, and I can say while, so it looks a whole lot like an if, right? It's going to have an expression here. So while, and then what comes after that is something that is true or false. One of those Boolean expressions, just like our if statements, something that is true or false. Because the computer can't do anything harder than that. It's either yes or no, right? We had to break it down. So we're going to say, well, number is greater than 0, colon. Now, everything inside this while loop will run if this is true. If it's true, it runs. So our silly example here, we're just going to print number, and then I'm going to say number minus equals 1. Right? Let's do that combined assignment operator, take away 1. Right? It's the same thing as saying number equals number minus 1. I'm just lazy. Right? We want to be efficiently lazy here. Right? Same thing here. So then number will get subtracted by 1, or 1 will be subtracted from number, and then when the end of the loop is reached here, so at the bottom of the loop, goes back and checks the condition. This is the loop condition right here. If it's true, it runs again. 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 So while it's true, this loop will keep on running, right? We'll run all the code in the block, and then come back to the top, check it. Run all the code to the top. So when it's not true, when it's false, it stops running. Right? So in our case, we should get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then at the end here, we can print blast off. Sure. And now we get a little countdown, and we blast off. Now the problem here, if we do the wrong thing, and I said +1 here, because I typoed, because I do that all the time here, I now have a program that doesn't stop. Because this while will never be false. Right? It's just going to keep on going. Okay, what are we at? 3 something million, I think. Let's print a formatted number here, right? So let's do a formatted string. I want number, was it colon, the decimal place, is that as a digit, right? D, I think that's it, right? Comma D, D for digits is how I remember it. I don't know why. It's not I for integers, but sure. There we go. So now we at least get the digit separator. All right, so now we're in the millions. And the program will just run as long as it keeps on running. So it turns out for Python, and for basically any programming language, what's really slow is printing something on the screen here, right? If instead of printing every single time, if I said, hey, let's do if number, how about modulus, let's do like 100,000 is 0, then I'll print. So I'm only going to print every 100,000. Right? So 100,000, if there's no remainder, 200,000, 300,000, right? Does that make sense here? Just adding this little check-in so that I'm not printing every single time. I'm still going to increase the number every time, but I'm only going to print occasionally. So now you'll see it prints really fast, right? So it's not slow at counting, right? It can add 1 really super fast. What it's slow at is printing to the screen, just in terms of processing power, right? Computers can add things really quick, right? So don't think it's slow to add. It's just slow to print because it has to catch up here in the console. That's all. So sure, so we can print. Again, you probably don't want it to do that here, so I'm going to go back to negative. We want to leave that. Does that help to leave these things commented here for you, or is that just more confusing? Okay. All right, so we can blast off. So the while loop runs while it's true, right? If it's not true, it doesn't run at all. Right, so this is known as a pre-test loop. So it's being tested before it ever runs. Right, so if number is based off of an input, like, hey, what do you want to count down from? We can say number is an int of an input. What do you want to count down from? Right? The user can pick, hey, I want to count down from 100. Sure. Because I'm super bored. Right? If I want to count down from -5, there's no countdown, right? It's never true, so the whole thing gets skipped, just like an if statement. It might not run here. You don't have to run here, right? Now we can print blast off. So we just skip it here, right? If you don't want to count down at all, sure. And users can give you some really weird stuff. So maybe we could do the, is it math.fabs, right? I think it's math.fabs. Yeah, fabs. I don't know why. But sure, you can do that, of an int of an input. So now we can do the absolute value, and they can't give me a negative number. And look at that, it added import math. How friendly. So now if I say -5, uh-oh, it's a float. Fabs here gives me a float. That's helpful. I don't know if you can see, it's kind of small here. It says define or def fabs, and then some other stuff here, supports float, supports index, and this little arrow notation, float. Gives me back a float. So if I want all of that as an integer, I'm going to go to int of math fabs of int of input. Sure. So that's why it crashed here. Now I can give it negative, and it's like, oh, you probably didn't mean negative, you're just stupid, because you can't count down from a negative number, right? That's really counting up. So it's not a count down at that point, right? Try teaching that to kids like on a number line. That gets fun here. I don't know. Math is very abstract. So, which is interesting here. I feel like I was just meeting with someone today and they told me they consider programming as a subset of math. It's like, Sort of, not exactly. I don't know. So before they had computer science departments, they had people with applied mathematics degrees. Our old department chair had a PhD in applied mathematics because he got into computers before computers were a thing, like, or they were just starting. He was pretty old, but like they didn't have a computer science degree. You couldn't get a PhD in computer science. It was applied math. So I get that idea here. So everything like computer science stems from math here, but again, very abstract. So code is abstract. That I'm writing something in English and the computer is kind of interpreting it, doing these things here. There's this cool, there's a good graphic here. What is it? Code rules of abstraction. This is a fun little rabbit trail. I think, is there a, this is probably a fine whatever our hit is here. So like the levels of abstraction that we work at, right? We don't need to do things at the machine level and tell the processor what to do and tell memory what to do because we're at a higher level of abstraction, right? We have a command that says, here's a variable, give it a value, right? If you're so blessed and get to take the assembly course, you'll learn to do this low-level nonsense and tell the machine to do, please do this with the processor, run this command in the processor, do this with your memory. It's a very low level here, not very abstract, right? So this idea that we're working with an abstract system, because we don't need to know all the details. I don't know what the processor does when Python tells it to add or subtract. I don't care what it does. It chips do something and we're happy with it. Super cool, right? So we're always working with this level of abstraction. So what we're doing is abstract here, but makes it interesting. Anyway, we're talking about loops. I got off track here again. So we can count with loops. We can do a lot of things with loops. Now, if we wanted to build our guessing game here, right? So let's do, we've got a number here. Let's change this. I'll leave it, I guess, here. So how about a highest number then is an int of an input of how high of a number do you want to guess, right? And I can pick a random number. So the random number is going to be random.randint from 1 to the highest number, right? And it says, oh, I don't know what random is. It's upset about it here. Unresolved reference random. It doesn't know what a random is. We want to import. So import this name. Perfect. It'll import. Now, we want random, not random.random. We'll talk more about that when we get to the modules chapter. It might make more sense. But for now, just import random. It's the easiest. So now this will work. So now I have a random number here. And I'll ask him for a guess. Right, so my guess then is an int of an input. Guess a number. 1, 2. And then I'll just do this in a formatted string here. My highest number. Now I can say while my guess does not equal the random number, right? If they guessed it right, I don't need this part to run. But if it's not right, I want to keep on asking them. So now I can say, hey, if my guess is less than the random number, I'm going to print too low. If it's not less than, right, it's got to be too high. Because I can't be in here if the guess is that number. I don't have three things to check. I don't have too high, too low, and is it matching? I just have it doesn't match. Okay, if it doesn't match now, is it too high or too low? Right? We've already eliminated one of those here. And then we'll ask them to guess again. So I'm going to change the value of guess. So with your loops, you want to be careful and make sure you're changing the value that you're testing. Right? What's in your condition? Make sure that's changing, because otherwise you're going to have an infinite loop. Right? So if I forget to ask them, I'm just going to be always too high, too low, because I never changed it. So we'll tell them too high, too low, and we'll have them guess the number. Eventually, maybe they'll probably enter the right number with enough hints here and with enough intelligence here. If you're smarter than a rock, you'll get the right number eventually. You can do 1, 2, 3, 4, 5, and eventually you'll get the right number here. It's not the hardest game in the world. Okay? So let's try it. Maybe at the end here, then we'll print. You got it. All right. So sure, we'll do a little countdown because I forgot to take that out. How high of a number do you want to guess? Let's do 100 here. So guess a number 1 to 100. What should we guess? 50. Yeah, split the difference. All right, 50 is too low. What should we guess?
65.
75. We want to split the difference, right? Always go halves here. 75 is too high. Oh, so I guess you were closer then. But 65? 65 is too low. So between 65 and 75?
68.
68? Okay, yeah. You try that. 68 is too high. Did you know what the random number was?
67.
67? We got it. We are a good guesser here. 67.
Close.
That was close, yeah. All right. So there's a guessing game. Now we could also like track the number of guesses. That's fun too, right? So we could have number of guesses. Number of guesses starts off at 1, right? Because they get 1 guess here. And then every time they guess here, then we'll take our number of guesses plus equals 1. And then we can tell them, hey, you got it in, as a formatted string here. Number of guesses, guesses. All right. All right, our little countdown, sure. How high of a number do we want to guess? Let's go a little higher. Let's go 1,000 here. So what should we start with?
500.
500, yeah, split the difference. Okay, too low. What next?
700.
700? Too low.
900.
900? Too high. Yeah.
876.
876, that's very specific. Too high. All right, someone said 800? Too high?
750.
750? Too high? So between 700 and 750? 725? Too low. All right, we're within 25.
735.
735. Too high. We're within 10.
730.
Too high. We're within 5.
727.
727. Too high.
726.
Hey, we got it in 11 guesses. Not too shabby here. This will keep you busy for a minute, and then it's very boring here. I don't know. My little kids, when they were younger, thought this was cool and would spend like 5 minutes playing it. My teenagers now just think I'm boring. It's just hard. When you get old, you get boring somehow. I don't know when it happened. All right, so this is our basic while loop, right? It runs while something is true. That's our loop here. Counting. So the next loop we're going to look at is a for loop. So for loops are different. So the idea with a for loop is it does something for each value in a collection or in a sequence, right? And remember we talked about a bunch of sequence types and collections, right? We have lists, we have strings, we have tuples, we kind of have dictionaries, right? It's like a set essentially, or you can have the key value pairs with the dictionary itself. You could do something for each value in that collection, right? So if I have, say, my name, right, is an int or an input of your name, and then I could say for letter in name. So the syntax is you say for, and then you give it a variable name. So it's for, and then this is some variable name in some collection. I should probably use my curly, my underscores. There we go. We'll match the right thing here. So what it does then, for each item in that collection, when this loop runs, it's known as letter. So I can print the letter. Now, the variable name here doesn't matter, just like any other variable name. It could be A, it could be X. Right? Python doesn't care. But what it's doing is, for every item in this collection of name, this loop will run one time. So it'll run once for E, once for R, once for I, and once for C. And it gets to the end of the collection, and the loop is done. So for loops run once for every item in the collection. Right? So it runs once for each item in the collection. So I'll count down, yep, sure, 0. Oh, that 0 is bad, sorry. 0, 1, there we go, 1, we guessed it. So Eric, then, I get ERIC, like we'd expect, right? I print the first letter, I print the second letter, print the third letter, print the fourth letter. Whatever I give it here for name, it's going to go once for each item here. Right? Now this gets to be fun, though, because now I can encode my name. Remember we looked at turning letters into ordinal values? Because that was entertaining to go back to Unicode here. So I could print then the ordinal value of the letter plus 1 turned back into a character here. Right? We looked at doing this one at a time here, right? We took some letters, we added some values to it here. So I should do that at the top here. Goodness. Eric. So now Eric, one letter shifted, F, S, J, D. Right? So pretty quickly with the loop, we can start adding things to it here and encoding it differently. And it works for any name now. I don't have to say what's the first letter, what's the second letter, what's the third letter, like we did last time. Right? We had to break it down letter by letter. This works for any length name. I could do my full name if I wanted here. Now, the space character plus 1 gets a little bit silly, but sure, why not? And then something I don't think we looked at with print yet. It might have been in Zybooks here. It doesn't have to add the new line every single time. Does that ring any bells? You can change the ending character in print here if you don't want it to be a new line. We say end equals nothing. Because I don't want it to go down a new line every time. I want it to stay smushed together like that. So now 0 and 1 and 1 and 1. There we go. So if I do Eric Chinesky here, Eric Chinesky, every character shifted by 1 is Dibsoftals. That actually kind of worked out. That's cool. I don't remember doing that last time. Right, so space plus 1 apparently is an exclamation mark. Sure, because all the characters have some sort of value here. They don't necessarily make sense here. Right? Or if I want to leave the spaces, I could do that too, right? I could say, hey, if my letter dot is, what is it, is white? No, dot is, goodness, dot is alphanumeric, is alphabetical, is ASCII, is a digit, is lower, is decimal, is numeric, is printable, is space. There we go. If it's a space, I don't want to do this, really. So I want to say if it's not a space, then do this here. Else, if it is a space, then I'm just going to print the letter. Right? This way it'll be a little bit nicer looking here. So 1, 1, 1, Eric Chinesky. So it'll preserve my spaces. Oh, did it not? I just got rid of it. Print the letter. It should have gotten the space there, right? Wonder why I didn't do that. If it's not, it's a space. Oh, I need to change the end though too. That's interesting. Print the letter. Why did I not get to that? I'm really confused. Let me try that again. I don't know why I did that. 1, 1, 1, 1, 1, 1. Eric Chinesky. All right, it worked that time. I don't know what happened last time. Maybe just because I didn't have the end. I don't know. It works now. Pretend like that didn't happen. Okay, so now I get to keep the spaces, which is nice. So I can give it a whole sentence here if I wanted. Oh, I don't want the debug here. I give it the whole sentence instead of my name here. So 1, 1, 1, 1, 1. So we can, I mean, whatever we wanted to give it here. And we get that all shifted by 1. Right? Kind of fun. Right? We get it to start changing letters. So you do lots of fun stuff with this and start encoding things, right? Encryption is the wrong word here. We can encode. So that's the for loop. So for each item in the collection. So if I had a list of meals then, right? We have for, I'm always hungry because this is right at lunchtime here. I'm sorry. So what did we say? We had some dinner options, right? We had, was it rice and beans? We had chicken. We had tacos. We had ice cream. Because you can have ice cream for dinner. You're an adult now. You can have what you want for dinner, right? So I can say for meal in meals. Now again, this could just be the letter X here. It doesn't have to mean something, but like any good variable name, you want it to be useful here. So you want to know what it is. So generally we'll give lists plural names here, plural variable names, and if you loop through them, you give it the singular, right? Because this is each item in the list we know as meals here. I can print the meal option, right? I should have done that at the top. Hang on, let me stop. I'll put this at the top here. Oh, no, I know what I can do. I can run the execute selection. There we go. I have to remember to do that. That's such a handy tool. And we get each item in that list all on their own line, because that's what print does here. Super fun. So it lets us loop through, right? We're looping, doing something once for each item in the collection. Right? Now, what if we wanted to make like a dictionary of meals then? So let's change this from meals, and we'll make this a dictionary. And maybe this then, what's our associated value? Like the number of calories, right? Rice and beans probably has like 500 calories. I'm totally making this up here. The numbers don't have to make a lot of sense here. Chicken is probably pretty low in calories, right? It's mostly protein. Tacos are going to be high calorie, I'm sure. And then ice cream is real high calorie as well. Right? So if I want to print for meal and meals, execute selection in Python console. Notice it still works, but I don't get the associated values. So for loops with dictionaries give only the keys. Dictionaries, too many C's there, right? So when you loop through with a for loop, you get each key in the dictionary back out. If you want the associated value then, we could print this as a formatted string here. Formatted string meal has, and then it's my dictionary key of the meal, right? Because if meal is the key, I can get the value associated from a dictionary by saying dictionary key of, here's the key. And I'll get the value associated with it here. So we can get out how many calories then in each meal here with our silly example. Let's run that. And now we see we get the key and then the value associated with that key, just like we asked for. So you can loop through dictionaries, you can loop through lists, you can loop through strings, you can loop through tuples, right? Each of those here. Now, when you get to strings, though, this is kind of fun. Remember, lists are mutable, so we expect we should be able to change things in a list, right? So if I wanted to say, should we go? I already did meals. What else should we do? Classes. How about classes? We'll do a list of classes. So we had CIS 1501. We had, what is it, like math 710, 170, I forget. 115, thank you. I'm forgetting all my numbers here. And then we had, there's something like take physics or chemistry or something? Chem 110, I don't know. We've got some numbers here. So if I want to loop through my classes, right, so for class in classes, now notice class is in orange here. That's a reserved word. If it shows up in orange, it has a special meaning in Python. You can't call a variable name for, you can't call a variable name in, you can't call something class here. So what do I want to do here? What do we want to call it instead then? So how about my class? Sure, just to get rid of that orange here. So I can take my class and I can lowercase it if I want, right? I can take my class equals my class.lower. Then we can print my class. Right, so we'll lowercase it and then we'll print it out. And then when I'm done, I want to print classes. Print the whole list here. And if we give this a run here, we get the lowercase versions from the for loop, but when we're done, they're still uppercased in the list. Lists are mutable, I should be able to change them here, but there's a weird thing that happens with these for loops here. So items in for loops are essentially copies. So when I say for my class in classes and I get the first value back out, I get CIS 1501, I get a copy of that. So when I change my class, I'm not changing the version that's in the list. I'm changing the copy that I have. This gets to be a little tricky sometimes when we start working with lists and trying to modify them here. Right? That's if we use this for loop. Now, the other cool thing we can do with loops here and for loops here, there's a value we have, right? Remember you can get things out by index and you can change things in the index of a list here. So if I want to go through every item in a list by index, I could say for index in range. So range says, hey, I'm going to give you from 0 up to a number you ask for, but not that number. It's actually very helpful that it stops here. So if I want to go through every class in classes by index, I know I have indexes 0, 1, and 2 here. So I want to stop at 2, so I need to give it 3. So I want to range up to 3. Well, 3 happens to be the length of classes, right? So if I range through the length of a list here, I'll get out all the indexes. I'll get 0, 1, and 2. If I have 7 classes, because you want to take a ton of credits because it's free after 12, well, sure, then we're going to have 7 classes in our list, and you're going to fail some, because that's just insane, right? But you can try it. So if I want now I can print the classes index of the index here. A lot of people love I here. I hate I. The reason I hate I is because I always get I confused with J's. Just it's hard for me to see. So I will always spell out index. Almost no one else does. But that's just my weird style preference here. So I can print the classes of index here. So this then will print them again, like we'd expect. So we're getting out the uppercase versions here. But now if I want to change what's there, I can say classes at the index equals classes at the index of index.lower. I want to lowercase and change what's stored at the list at this index. This will change it permanently here, because it's not this copy that we have called my class here. It's saying in the list itself, go change the value stored there. So we're able to actually change it with that notation here, with ranging through. Let me run that one again real quick. So now we see they end up lowercase when we're done. So if you want to change values in the list, you have to loop through by index here. So looping through by index to change the values stored. right? Versus the regular for loop, they're read-only copies, right? They're copies here. You can't go change them. There's a couple things we'll clarify eventually when we get further in, but for now, this rule is what it is. I'll show you how we can break that later. But for now, this is what we get here. So I can loop through items here by range of a length of something if I want. Or I don't even need to use a list here. I can just loop through a range, right? So if I said, hey, guess the number here, right? Let's come back up here. So I have the number here, right? It's an integer. I can say for value in range number, I can print the value. Now this is going to count upwards at least though, right? So if I say 10, I'm going to get 0 up through. Now the 9 is actually where this one stops here, right? The 10 is from when it's printing number here, right? So sorry, maybe I should just run just this part here because it's only going to run, oh goodness, there we go, insert, all of that. So if we do 10, right, it stops at 9 because you don't get that last value with a range here. But it's quick to go this way. Now what else range does for you is you can say, here's the start value and here's the end value. So if I want to range specifically from like 2 to the number and get rid of the number 1, it will start counting at 2. I don't know why you'd want to do that, but you could if you wanted here, right? So then we'll run this bit here. Let's count down. So now we get 2, 3, 4, right? So we get a start here. The other fun thing you can do is you can give it another optional value here is the step. Say, what do you want to count by? Usually we count by 1s, right? 1, 2, 3. If I want to count by 2s, now I'll get 2, 4, 6, 8. No one says who do we appreciate? Really? It's not in the mood to sing? It's okay. Right? We get 2, 4, 6, 8. So because we're stepping by 2. So you get a start, you get an end, and you get a step. The start is optional and the step is optional. Right? Usually you just tell at the end here and you start at 0. If you don't want to start at 0, you don't have to. Now the other thing we can do though is we can change this and say, hey, I want to go from number as the start to 0 and I want to step by -1. So you can count backwards by starting high, going low, and counting down. So range is pretty flexible. You can do a lot of cool stuff with range. So now my countdown works like I'd expect. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 with a for loop instead of a while loop. Right? Hooray. We used a different kind of loop to do the exact same thing. Just like anything else in programming, there's always like 5 different ways you can do anything. It'll get the job done. A lot of it's just a style preference here. So we can use range here to do lots of cool stuff. Okay? The next fun thing we can do here is let's print some shapes, and this will help get us started for lab here because I love shapes. You guys ever done ASCII art before? ASCII art. ASCIIart.eu. Sure. Let's see, buildings and places. No, I don't want the ad. Close the ad. Castles. It's pictures you draw with characters. ASCII, right? That's the characters, kind of like Unicode. This is ASCII art. Look how fancy these are. They even did birds. That's fun. This is what people used to do when they were really bored way back when, before we had pretty graphics. But people still do them because they're like sort of challenging and interesting here. It can be fun things here. So we're going to do ASCII art, but really boring stuff because it's hard. Look at those seagulls. Those are like fancy birds. I don't know what this one is over here. Oh, there we go. Like a real. That's his beak, right? That's the real big one. Real big bird. And clouds, pretty clouds. They have like bushes and trees. Some people try really hard. So I feel like there was a way, one of the AI chat tools would, like, you could take a picture and ask it to give you an ASCII art version of it, and it would do something like that. I'm trying to remember which one it was, but it's not that important. Anyway, so if we want to do some ASCII art, ours will be really boring here, but we're going to make a square, right? We can print a square pretty easily. So I'm going to ask them then, so the length or size, that'll be an int of an input. How large of a square should we print? Okay, and then what I want to do is I want to print that number of characters. So I want to say 4, then this is what row in size. I want to print, in range size. There we go. That's why it was upset with me. in the range of size, right? So that if you wanted size 10, I'll get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to print a star character times the size. Remember we did this way back when with arithmetic? You can multiply strings. Doesn't really make a whole lot of sense up until now. And now it's amazing. So if we do a 10 by 10, it doesn't look very square because of the spacing here. It looks like a rectangle, but it's a square. Just trust me, it's really a square, right? We get 10 of these, right? 10 stars, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have 10 rows, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 by 10, like we'd expect here. We can print out a square, right? That's real fancy. So we can start doing this interesting ASCII art here with ranging over sizes here, right? Now, a little bit trickier here. What if we wanted to do a triangle here, right? So like 1 star at the top, and then 2 stars, and then 3 stars, and then 4 stars, and then 5 stars, right? So I'm going to get star, instead of by the size, I want to multiply it by the row plus 1. I want to do that in parentheses here, right? 4 set order operations first. So at row 1, I want 1 star, which really is row 0, right? Because we always start counting at 0. But 0 times something is sad, right? You get nothing. Okay, so now instead of a square, we get a triangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, and on and on and on. We get some cool shapes, right? What if we wanted to make this triangle, instead of lining up on the left side, line up on the right side? Well, we have to print a bunch of spaces first, and then our stars. Right? We could do that. So we're going to print then the space character, and how many of those do we need? Well, we need the size minus the row minus 1. Right? And then we want to change that ending character to not go down a line, because we don't want to go down until we get to the next one here. So this will be the first row then, at row 0, I should get 10 minus 0 minus 1 is 9. I want 9 spaces, and then 0 plus 1 stars, 1 star. And the next time I want 8 spaces and 2 stars, and then 7 spaces and 3 stars, and 6 spaces, right? I want to go this way here. So let's give that one a run here, so 10. And we get it this direction. We lined it up that way. Now we don't have to use a for loop, right? We could use a while loop for this too, right? We could say while something is true, right? If we wanted. So to print a triangle, right, I'll have my stars equals 1, and while my stars, while stars is less than size, right? I want to print, well, what do I want to print? Let's do the left aligned triangle to start here. So we'll just print this times the stars. And how about less than or equal to size, right? Because we're starting at 1, right? This way it'll run from 1 to 10 here, or whatever we tell it here. Print that times the number of stars. Now this loop will be infinite unless we go change something, right? So we need to change the number of stars by 1 each time. Right? So we can also use a while loop to print it here instead of a for loop. Right? Now a while loop gives us 1 star, 2 stars, 3 stars, 4 stars, 5 stars, 6 stars, 7 stars, 8 stars, 9 stars, 10 stars. Right? Because it's running as long as this is true. So you don't have to do everything with for loops here and ranges. You can also use while loops. We got lots of options for how we want to manage with these here. Okay. Now the fun thing is you can put a loop inside of a loop here. So this is how large of a square here. Let's go back to, how about rectangles? So let's do length and width. So length is int of an input, how long of a rectangle, and a width then of an int of an input, how wide of a rectangle. Right? Now, I'm going to do this the hard way just to show you can put a loop inside of a loop here. Right? And it'll work out okay. So I'm going to do the same with a while loop, and then we'll do the same with a for loop. So we can do it both ways. So which one do you want to do first? The while loop or the for loop? The while loop. Okay, so we'll say then row is 1. And while row is less than or equal to length and width. Which one is going to be up and down? Call that length. Okay, cool, length. So for every row then, I need to print with number here. So I can put, now this is, I don't know, stars is 1. And I can say while stars is less than the width, less than or equal to the width. I'm going to print a star. I'm going to change that ending character to be nothing here. And I'm going to say stars plus 1. Now this one seems kind of silly here, but it's going to print one star at a time. Instead of doing this printing like multiplication here, I'm just going to print one at a time. Okay, and then the loop will run again and print another one. The loop will run again and print another one. So this loop runs from start to finish for every time this one, the outer loop, runs. So a loop inside of a loop. And then when that one's done, then I'll take row plus equal 1. So I should be able to get a nice little rectangle here out of this. So 10 for our triangles. All right, how long of a rectangle? How long? 12? Okay, so it should be 12 long and how wide? Or 12 tall and how wide? 20, okay. Uh-oh.
Oh, that was too big.
So I need to print at the end of each row, I need to go down a line. That's my bad. Let's try that again. All right, so we did 12 by 20. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 rows. And is that 20 stars? That's probably 20 stars. 19 characters. Am I off by 1? 1, 2, 3. It's probably 20. It's probably pretty close. I don't want to count them all right now. I'm feeling lazy. Here, I can count them in Notepad. Notepad's good at counting. There we go. Yeah, Notepad is 20 characters right there. All right, so we had 20, pretty easy. A loop inside of a loop. Other silly things would you put loops inside of loops here. Imagine you wanted to show every single time on a clock, because just imagine here, because this is very useful here. So I can say hours is 0, minutes is 0, and seconds is 0. And we're going to start off at 0, 0, 0, 0, right? And then while my hours is less than 24, now I want minutes to be 0, right? And while minutes is less than 60, now seconds can be 0. And while seconds is less than 60, we're going to print as a formatted string here, right? We want to pad this. We want at least 2 digits here, right? So it was hours colon, is it 2D, right? For 2 digits, I feel like. This was probably pretty close. And then a colon, and then minutes colon 2D for 2 digits there, and then seconds colon 2D. It's probably pretty correct here. We'll see. Let's see if that gets us for it. No, it's not doing the padding. Is it 0? 0, 2D? There we go. Uh-oh. I didn't increase anything ever. We're at infinite loop, always 0 here. So seconds plus equals 1. When the seconds loop is done, then minutes will go up by 1. Minutes plus equals 1. And when the minutes loop is done, then my hours plus equals 1. So getting these in the right order is kind of important. So for every hour, then, we're resetting minute back to 0. Right? When this loop runs at hour 0, minute starts at 0. When we get to hour plus 1, we come back up to the top. 1 is less than 24, yes. Minutes starts back at 0. We're resetting it. Right? So we're in the right spot here. Now we get all the possible times in a 24-hour time clock. This is the right way to tell time, right? This 12-hour nonsense is silly. There's also the right format for dates as well, but we'll get into that later. Right? So you can put a loop inside of a loop, 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 so you're blue in the face. Python doesn't care, right? It's going to go line by line by line and say, okay, if this is true, run the loop. If this is true, run the loop. If this is true, run the loop. We just keep on going. So you can do all sorts of fun stuff. We'll do some printing here. Oh, I was going to do for loops as well, right? So this was the while loop. So if I want to do a for loop then, so for, this is what, row in range, the length, right? This will be from 0 up to this number, right? Now, if I wanted, I could go 1 and length plus 1, right? This way I count from 1 to 10 or 1 to 12, whatever the length is going to be here. Right? You can give it an optional start if you want, and it doesn't include the end. So if I go plus 1, then I'll get the actual end. And if I want to say for, I don't know what this is, star in range 1 to width, or we can just do width here, right? Because we don't actually need the values here. I can print a star, and I'll change my end character to a nothing. And at the end of every row, then I want to print just to go down a line. Right? So instead of having to remember to add 1 here, add 1 each time, the for loops with ranges just works for me here. So 1, all right, how long of a rectangle? Would it be 12 by 20? We should get it twice here. So now we have 24 by 20. Right, they look the same. Worked out well with for loops and while loops. Just different ways of going about it here. And again, if you could count differently, you can use your steps. You can go up and down. You can do different things here. For lab, we'll do some different shapes here. You can do some fun ones, okay? There's diamonds, there's equilateral triangles instead of like left aligned or right aligned. We can do some fun shapes here, and they're practice using loops. That's sort of the goal here. That make sense so far? All right, so we didn't get to all of loops. There's definitely a lot more we're gonna get into with loops here. This break and continue stuff is a little bit confusing. We'll get to that as well. And then because a loop is kind of like an if statement, you can also have an else, which is also kind of weird, but it'll make sense after we do break and continue. And then enumerate's a fun little shortcut. And then dice statistics. This one's my favorite. We'll also do this in lab here. We'll do a similar thing. So if you want then, here, I'll show you the like 6-sided die statistics. So that's fun here. So I'm gonna make a list here. So this is count of sides, then will be a list. And I can do it by hand if I want here. So the number of times that each side has been rolled. Right, on a 6-sided die there's 6 spots here. There's 6 sides. Count of sides being rolled. Right? Count of side being rolled, I suppose. Right? So then if I want to roll a die a bunch of times here, right, I can say, I don't know what, for roll in range 100. We'll roll 100 times here. Every time we roll the die, let's pick a random number. So the number then is random. Randint, where is it? There's that one. Nope. No, goodness. Random, randint. I want 1 to 6 because I'm rolling a 6-sided die, right? Now, I'm going to get the values 1 to 6 here, but I have indexes 0 through 5. So I'm going to take my count of sides being rolled at the index of the number minus 1, right? Subtract 1 to the matching index, right? So index 0 will represent the number 1. Index 1 will represent the number 2, right? Sure, we can do it that way. We're going to take that and we're going to add 1 to it because that side was rolled. And we're done, and we're going to print, right? Or I can say for count of sides being rolled, we're going to print a formatted string and say the number. Well, I need the indexes here, right? If I want to know the numbers. So I can't just say for the value in here, right? So I need for index in range, the length of the count here. And then because I'm off by 1, I'm going to take my index plus 1. Right? So index 0 represents the 1s, index 2 represents the 2, or index 1 represents the 2s, and on, right? Was rolled. And now I want the value at that index here. So the count of sides being rolled at the index of index here is the value associated with that. So if we want to roll 100 times here, we'll see how many times each number showed up. Oops, what am I? Missed my colon here, right? It's expected a colon. Go back up to the top. Come on. So if I roll 100 times, I get 13, 14, 20, 19, 18, 16. Just looks pretty close to random, right? It's not going to be a perfect distribution here because it's supposed to be sort of random here, right? So the more times we roll, the closer we'll get to that percentage here. Right? So if I wanted to print that as a percentage, right, we could print the total time here, and then I kind of want to go on the same line. Let's go down a line here and just concatenate these things together here. I think that works here. So the percentage then is going to be the value. Too many curly braces. Divided by 100, right? Because I rolled 100 times. Percent. So we'll see that then. Oops. It's not actually. Oh, goodness. Oh, that is the percentage because it was out of 100. That's silly. So we should have number of rolls then. Number of rolls is an int of an input. How many rolls? There we go. Now we can go off of this here. Divide by the number of rolls. But if we wanted the percentage, then we have to multiply by 100. Right? So it looks like whole number percentages. All right, so how many times should we roll? Do you like just 20? Just start with a low number. Right, it got kind of skewed here, right? We had 30% of them were 5s, 25% of them were 1s, only 1% of them were 6s. Right, kind of low here. But as we increase our number of rolls here, then run that again here, and we do like 10,000 rolls here, we're going to get closer to the expected distribution of a 6th each time. Right? They're all a lot closer to a 6th the more we do here. So that's kind of fun. And then we can take that number and we can actually turn it into a little histogram, which is really cool too. So we'll do that in lab. All right, we'll head over to the lab building. I'm going to grab some coffee and we'll get working on that. I didn't talk about the project. Crap. I posted it. It's quick. Give me like 1 minute here. It'll just 1 second to go over it. Sorry. We're going to build a little lunar lander simulator here. So it's going to use some loops. So we have a bunch of commands we can use. So when you send the lunar lander out, then you can give it some commands. We're going to say it starts 10 units from the surface. Whatever unit of distance you want here, doesn't matter. And it is tilted on the x and y axis, somewhere between -10 and +10. And we need to fix that so we're not tilted so we can land nice and flat here. So we can send it an x-axis tilt, positive or negative, to change it +1 or -1, a y-axis tilt change, +1 or -1, a thrusters to increase the distance from the surface by 2, a do nothing, just keep on going down. And you can activate self-destruct here, because all good spaceships have a self-destruct sequence you can activate. In our case, the only thing you can do is cancel it, because it's always a bluff. Right? You don't actually want to self-destruct, it's just a bluff. And then we just keep on running this little loop here, saying what command do you want until the distance gets to be 0. When the distance gets to be 0, if the x and y tilts are 0, we successfully landed it. If they're not 0, the lander broke. And we said, oh, you crashed the lander, good job. And then all of this is in a loop that says, do you want to play again? I'll talk more about it Wednesday, but if you want to think about it, and we can talk more about it in the lab. All right, thanks.